Hello and welcome to the class on binomial distribution. We have studied frequency distribution, where the large raw data was condensed in the form of a table. Another type of distribution is a probability distribution, which is used to calculate the probability of occurrence of an event. Probability distribution can be presented as an equation. It has its own mean and the variance. There are various probability distributions according to the nature of the variable, such as binomial distribution, Poisson distribution, and normal distribution. The binomial distribution describes the distribution of discrete events that can be classified as occurrence of the event or non-occurrence of the event. Suppose an experiment consisting of n number of trials is conducted. The probability of occurrence of an event is P in each trial, and the probability of non-occurrence of the same event is Q in each trial. Now, the probability of getting exactly specific number of occurrences can be obtained by the expansion of P plus Q raised to n. The probability distribution so obtained is known as binomial distribution. For example, if there are 5 coin tosses, what will be the probability that we get exactly 3 heads? One of the way to get exact 3 heads is HHHTT, and another way of getting exact 3 heads is THHT. Now, 0.5 raised to 3 into 0.5 raised to 2 is the probability of each unique arrangement that has exact 3 heads. The overall probability of getting 3 heads will be the sum of these unique probabilities. The total number of outcomes or exact arrangements can be obtained with the formula NCR. The probability of each unique outcome will be one and the same, and therefore the probability of getting 3 hits can be computed as 0.3125. Assumptions for binomial distribution are that the events should be discrete events and the value of P and Q should be constant. The properties of binomial distribution are that if P and Q are equal or n is very large, the binomial distribution will tend to be symmetrical. The probability can be obtained by the expansion of P plus Q raised to small n. If the experiment is conducted large number of times, then the observed frequencies will approximate the expected frequencies. The mean of binomial distribution will be NP, the variance will be NPQ. As the n increases, the binomial distribution becomes smoother and approaches the normal curve. The expansion of various binomial expressions is exhibited in this slide. For expansion of any binomial expression, we need to find out the coefficient and the power of the given terms. And the number of expansion terms will be dependent on n. For example, if n is 2, the expansion will be n plus 1, that is 3 terms. The coefficients of the terms can be obtained with the given formula. The slide presents obtaining coefficient of the various terms when n is raised to 4. The Pascal's triangle can also be used for calculating the binomial coefficients. This is a Pascal's triangle where all the edges are 1 and the two numbers in the above row are added to obtain the number below. And thus the triangle proceeds. To get the coefficient for expanding to the 5th power, we will be using the row that starts with 5, and the numbers will be used as the coefficients of the answering terms. For any value of n in the first term, the power of P will be n and the power of q will be 0. In the second term, the power of p decreases by 1 and the power of q increases by 1. The process continues till the last term of expansion, where the power of p becomes 0 and the power of q becomes n. This is the general expansion of the binomial expression, where the general factorial formula to obtain probability of R events in n number of trials can be obtained with the formula NCR into P raised to R into Q raised to n minus R. The binomial distribution can be expressed in a tabular form. The applications of binomial distribution are in cohort study and in case control studies. Thank you.